Welcome to my class. In this particular video lecture, we will talk about grid computing. The term grid computing takes us back to the concept of power grids. To turn on an electrical appliance, we just need to plug it to the nearest power outlet, that is the wall socket, and switch it on. The result is now we can operate the electrical device. We need not know from where the power has come or what path electrical current flows through, where it was generated from, and the different operations performed to transmit the electricity to our device. With grid computing, essentially the things are the same. User can have access to computer resources with no or little knowledge of the place where these resources are located and what are the underlying infrastructures, operating systems, hardware, or other softwares. This is a diagram of grid computing, and in the case of grid computing, we have three different entities. The first one is resource provider, the second one is control node, and the third one is user organization. In the case of grid computing, we make use of idle capacity of resource providers, idle storage capacity, idle processing capacity of resource provider. There is one particular computer, that is control node. That control node shall assess the powers of resource provider and transmit it to the user organization. In a way, user organization can make use of resources provided by the resource providers. In a way, user organization through control node can make use of idle resources provided by the resource providers. Grid computing is a technique in which the idle processing power and storage power of computer systems in the network can be efficiently used, and making network into a single large virtual system for resource sharing dynamically at runtime. There are certain tasks which needs to have a great processing power and storage power. We can make use of idle computers to contribute to the processing power and storage power. It will make the system look like a large-scale virtual system in which the resources shall be shared dynamically when the computers are switched on. Grid computing can be defined as a network of computers working together to perform a task that would rather be difficult for a single machine. All machines on the network work under the same protocol to act like a virtual supercomputer. The tasks that they work on may include analyzing huge data sets which require high computing power. Computers on the network contribute resources like processing power and storage capacity to the network. In simple words, grid computing is a group of computers physically connected over a network or with internet to perform a dedicated task together, such as to solve a complex problem. Grids are a form of super virtual computer that solve a particular application. Who invented grid computing? The idea of grid computing was first established in the early 1990s by Carl Kesselman, Ian Foster, and Steve Tukey. They developed the Globus Toolkit standard, which include grids for data storage management, data processing, and intensive computation management. Types of grids. Grids can be classified into following three types: computational grids, scavenging grids, and data grids. The first one, computational grid. In this type of grid, the emphasis is on computational performance. This means that the problem assigned to this type of grids are of complex computation and high performance. Scavenging grids. This type of grids are used to search and exploit machine cycles on idle computers for using in resource intensive and computationally intensive tasks. Scavenging is a technique that makes use of instruction cycles on desktop computers that would otherwise be wasted at night, during lunch, or even in scattered seconds throughout the day when the computer is waiting for the user input or slow devices. A data grid provides set of services that gives individual or groups of users the ability to access, modify, and transfer extremely large amount of geographically distributed data for research purposes. Data grid provide a unified interface for all data repositories in an organization and through which data can be queried, managed, and secured. Who uses grid computing? Grid computing is used in research and education along with many other areas. Grid computing aims to make all computing resources available constantly on 24/7 basis. Many large corporations such as Boeing and Pratt & Whitney are currently using computational grids to improve their operations. Grid computing is a subset. It is a part of distributed computing, where a virtual supercomputer comprises of machines on a network connected by some bus or sometimes the internet. Here bus means wire. It can also be seen as a form of parallel computing, where instead of many CPUs on a single machine, it contains multiple individual CPUs on a multiple machines spread across various locations. How does grid work? A grid computing network mainly consists of these three types of machines. The first one is control node. A computer, usually a server or a group of servers, which administrates the whole network and keeps the accounts of the resources in the network pool. So this is the computer or a number of computers which manages the network, which manages the resources available on the network. The second one is resource provider. These are the computers which contributes its resources in the network resource pool. The third one is user. The computer that uses the resources on the network. It can also be termed as a user organization. When a user computer makes a request for resource to the control node, the control node gives the user computer an access to the resources available on the network. When the resource provider computer is not in use, it should ideally contribute its resources to the network. Hence, a normal computer on the node can swing in between being a user or a provider based on its needs. The computers connected to grid may consist of machines with similar platforms using same operating systems called homogeneous networks. Second, and machines with different platforms running on different operating systems called heterogeneous networks. This is the distinguishing part of grid computing from other distributed computing architectures. The meaning of the term grid computing has changed over the years. Now grid computing is viewed as a distributed collaborative network. What are the advantages of grid computing? First, it is not centralized, as there are no servers required except the control node, which is just used for controlling and not for processing. Second, multiple heterogeneous machines, that is, computers with different operating systems, can be used in a single grid computing network. Third, tasks can be performed parallelly across various physical locations and the user don't have to pay for it, that is, money. Fourth, it can make use of unused computing power and thus it is cost-effective solution, reducing further investment. What are the disadvantages of grid computing? First, internet connectivity. It requires a high-speed access to the internet. Second, security, which is a serious problem. Users are accessing the grid via the internet and this makes working with the grid vulnerable. Third, not easy to build. Compared to cluster computing, it also needs more and more capabilities and skills to create a grid or to make resource provider join the grid. Fourth, administration. To administer a grid is difficult in comparison to cluster computing. Fifth disadvantage is dependent operation. If the operations currently under execution depends on the previous task, then processing cannot be done in parallel on distributed resources. Therefore, the application cannot benefit in the grid in terms of high performance computing if the operations are dependent on each other. Let us take up an example of grid computing. The search for extraterrestrial intelligence SETI is a scientific search for intelligent extraterrestrial life, for example, monitoring for signs of transmissions from civilizations on other planets. The SETI project is an attempt to discover signal from intelligent life outside the solar system. It analyzes signals from outer space, which requires tremendous computing power. We need to have number of supercomputers to analyze this data. The SETI at Home project uses grid computing to analyze signals acquired from other planets. Any individual can become involved with SETI research by downloading the Berkeley Open Infrastructure for Network Computing, that is BOINC software program, attaching to the SETI at Home project and allowing the program to run as a background process that uses idle computer power. After computation on the work unit is complete, the results are then automatically reported back to SETI at Home servers at University of California, Berkeley. With over 1,45,000 active computers in the system in 233 countries as of 23rd June 2013, SETI at Home had the ability to compute over 668 teraflops. Thank you very much.